everyone, welcome to another video. In this video, we will talk about the chemical properties of minerals. We have two major classification of minerals. We have the silicate and the non-silicate minerals. When we say silicate, it contains both silicon and oxygen atom. So parehong merong silicon and oxygen atom. When we look at the chemical composition of a mineral, tapos nakita natin meron siyang SiO4, okay, na nakasulat, it means the mineral belongs to the silicate group. Now, the other one is the non-silicate group. It can either contain silicon or oxygen or neither. Okay? Kung meron siyang isang, kung ang silicon ay present doon sa chemical composition niya pero wala yung oxygen, therefore the mineral is non-silicate. Also, if oxygen is present and the silicon is absent, then the mineral is also non-silicate. Okay? The silicate minerals are most abundant minerals in the Earth's crust. So mas marami ang silicate kesa sa non-silicate class. When we say silicate class, they are largest and abundant group of minerals that contain silicon and oxygen with some aluminum, magnesium, iron, and calcium. So, a silicate class must contain a silicon and oxygen atom plus other elements such as aluminum, the magnesium, iron, and calcium. About 25% of the known minerals and nearly 40% of the common ones are silicates. Nearly 90% of the igneous rock-forming minerals are also silicates, which means they make up over 90% of the Earth's crust. Also, aside from the silicate, we also have the oxides that are also dominant mineral group. Later on, we will talk about the oxide class, which belongs to the non-silicate class of mineral. The soil where we grow our food is made up of mostly silicate minerals, such as the bricks, the stones, and the glass are silicates, or derived from silicates. Now, the fundamental unit of silicate consists of 4 oxygen ions surrounding the silicon ion, or also known as the silicon-oxygen tetrahedron. Okay, katulad halimbawa ng feldspar, ng quartz, and ng garnet. Okay, so always remember that kapag merong siyang SiO4 sa kanyang composition, it means it belongs to the silicate class. Now let's move on to the non-silicate class. The first one is the carbonate class. These are based on the carbonate ion CO3. So take a note of this. Meron siyang O3, no? It has oxygen atoms. However, we cannot consider it as a silicate class because wala siyang silicon. These minerals are commonly formed in sedimentary and oxidizing element. They are also divided into 3 groups. We have the calcite, the dolomite, and the carbonate. Okay? Okay, or the aragonite. Okay? Aragonite. Carbonate class are transparent, no? And are lightly colored with a white streak, have average to above average specific gravity. They are also soft with good to perfect cleavage, soluble in acidic solution. So natutunaw sila sa acidic solutions. The next one, we have the sulfate class. It forms in areas with high evaporation rates and where salty waters slowly evaporate. The sulfate minerals are a class of minerals that includes the sulfate ion, okay, within their structure, or the SO4. The sulfate minerals occur commonly in primary evaporite dispositional environments. Okay? Katulad halimbawa ng anhydrite, ng celestine, and even the gypsum. The next class is the halite class. It contains natural salt sand, no? That includes fluorite, halite, sylvite, and salammoniac components. The minerals that make up the halide class include those in which the halogen elements, no, of chlorine, bromine, fluorine, and iodine, and are combined with one or more metals. Okay? Dito naman sa halide class, the mineral contains an element of chlorine or bromine or fluorine or iodine, which was combined or were combined with one or more metals. Like for example, the halite. The halite is what we call the rock salt. Okay? We have the sylvite and the fluorite. The next one is the oxide class. It contains oxide ions or O2, which is binded to one or more metal alloys. Okay? The hydroxide-bearing minerals are typically included in the oxide class. Several species of oxide minerals are also quite useful for industrial purposes and hold significant economic value. Most of the oxide class are dark in color, like for example the hematite, the magnetite, and the chromite. The next one is the sulfide class, in which the sulfide mineral, it can also be spelled as PHIDE. They are any member of a group of compounds. So take a note of this. Sulfide class, okay, group of compounds of sulfur with one or more metal. So it is a sulfur combined with one or more metals. So the metals that occur most commonly in sulfides are iron, the copper, the nickel, lead, the cobalt, silver, and zinc. Most of the sulfides are simply structurally exhibiting high symmetry in their crystal forms and have many of the properties of metals. That includes their metallic luster and their electrical conductivity. Okay? They often are strikingly colored and have a low hardness and a high specific gravity. The next class is the phosphate class. Like the silicate class, no? The phosphate class contains a tetrahedrally coordinated phosphate ion, right? Or the PO4, the phosphorus and oxygen atoms. It can be used as a source of fertilizer in growing food, no? Mineral found in the teeth and bones of many animals. Like for example, we have the arsenic, the phosphate, and the vanadium. Okay? Now, as you can see, the arsenic and the vanadium are single element mineral, which can be combined with phosphate, okay, to make it a phosphate class. And lastly, we have the native element class. When we say native element class, these are minerals that are composed of atoms from a single element. Okay, so isang element lang siya, wala nang ibang halo. Like for example, the gold, okay, the bismuth, and the graphite. So that's our lesson for chemical properties, and I hope you learned something. And thank you for listening. Have a good day.